love calculus. It's the most is fun. All right, okay. So, the first 4 slides that we have here, okay, you should already know the first 2. So, these are trig identities that we're going to have memorized, okay? We're going to have a quiz. When are we going to have the quiz? Well, let's see when we're going to have the quiz. So, this particular quiz, though, is not on how to do this. So, it might be Friday. Let me see where I said. Yes, Friday. But, look at this before you panic. Look, Lily's panicking before she even knows what it is. Okay, I did. Because it is a memorization quiz, it should be an easy 100. Right here's the answer key. It's posted on Canvas already. Okay? The answer key to the quiz is posted. Yeah, I want you to memorize this and cheat on it. I mean, I'll send you to the office if you got a cheat sheet and you're checking your sleeve here. But if you want to cheat by memorizing all these answers and then writing them down on the quiz whenever I give them to you, go ahead. Yeah. There's going to be a real quiz too, where you have to be able to do it. That will be next week. But our quiz Friday. All right. Okay. Our quiz on Friday will be this sheet. It will be blank, so I think I put a copy of the blank sheet also, so you can see what that'll look like. Let's see, I'll show you what the blank one looks like also. So, it just looks like this. Okay? So, you're going to have to list all of these identities, because if you do not know them, have them memorized well, then you're going to struggle on this section. So, we have to know them well. Students usually don't have trouble with this. I have a few slackers every once in a while that don't want to take the easy 100 that I'm giving them for that quiz, and they do bad on this quiz, but usually most of the class makes 100 on this, right? So reciprocal identities are just sine being 1 over cosine, cosine being 1 over secant, tangent 1 over cotangent, cosecant 1 over sine, secant 1 over cosine, cotangent 1 over tangent. So, those are our reciprocal identities. They're called reciprocal because when you do 1 over something, it flips it. Right. Yes. If you leave it off of 1, I'm not going to count points off. Like if you forget it on one little piece, I'm not going to take points off. If you do the whole identity quiz without putting any thetas on it, I'm going to take points off. X is fine. Yeah, you need a variable though. Yeah, X is fine instead of thetas. Yeah. Please don't use an S. Or O. But you do need a variable. A lot of students want to write these without the variables at all. And I don't want you to do that because there are some like double angle identities and stuff that we're going to do where it's not always just a theta right there. We're not there yet, but do put the variable. Your quotient identities, you also should already know these because we use them a lot for the unit circle, right? So tangent is sine over cosine, cotangent is cosine over sine. So you should hopefully already know those, but if you don't, you're going to memorize them. All right, this one is new and is going to be major. Now, if I go back to students who had pre-cal last year, they probably remember most of the first 2, probably. And they probably remember sine squared plus cosine squared equals 1. They probably don't remember these other 2 because we don't use them as often, but let me show you a trick for this, okay? So, for these second 2, if I know sine squared plus cosine squared equals 1, so that you got to memorize Pythagorean identity. It looks a little like a squared plus b squared equals c squared there, right? So this you just need to memorize. But the other two you can actually figure out without having to know the other two. Because if I take the first one, if I divide everything by sine squared theta, okay, what would sine squared theta divided by sine squared theta be? Cancel and it'd be 1, right? So that would be 1 right here. What's cosine over sine? It's cotangent, and it does still apply if it's squared. So if I have cosine squared over sine squared, it's going to give me cotangent squared. And what is 1 over sine? Cosecant. So there's that identity. That's also why they put the 1 first here and they don't here, because of the way that it's derived. So if you divide everything by sine squared, it gives you this bottom one. Now I'm going to erase that so I can go back. Where are you thinking, Caleb? If I divide everything by cosine squared, then sine over cosine is tangent. If I divide cosine by cosine, I get 1, and 1 over cosine is secant. So if you have that first one memorized well, you can kind of figure out the other two using those tricks. Or just memorize all 3 of them. It's fine too. It is okay, like if you write this as 1 plus tangent squared instead of tangent squared plus 1, that's okay if you don't have them in that order. They just did this order because of the way that you can derive them. There. Okay? So we got reciprocal identities, quotient identities, Pythagorean identities. We are going to use those 3 a lot. We will not use opposite angle identities quite as much whenever we are doing these problems. We'll use it occasionally, but they won't show up quite as often. So a lot of students forget to memorize opposite angle identity, so don't forget it. It is on the identity quiz that you guys will have on Friday. So sine of negative A equals negative sine of A. Okay, so an example here is going to look like this. Now, unit circle wise, I could just go backwards on the unit circle. This is just sort of like a different approach. So if I've got sine of negative pi over 6, it's going to be equal to negative sine of pi over 6. And on my unit circle, sine of pi over 6, what is it? 1/2. Okay. Now, cosine of negative A is just equal to cosine of A. So if I have a negative and a positive of the same angle, it's going to give me the same value. So cosine of 3 pi over 4, or negative 3 pi over 4, would equal the same thing as cosine of positive 3 pi over 4. And positive 3 pi over 4 is in here. It's negative root 2 over 2, right? Yeah. Yeah. Okay. So we will not use this as often. And really, as far as unit circle goes, you can use this property if you want, or you could just figure it out without. You could just go backwards on the unit circle, right? You don't have to know it to find unit circle values. So this is not as important, but it is on the identity quiz. So please make sure that you memorize it, okay? Yeah. All right. So here is what we will be doing with these problems. I love these problems, by the way. It is not my favorite thing to teach, necessarily, just because it is sometimes difficult for students, and sometimes I wish I had, like, better ways of explaining it than I do. But I love doing these problems. So when you're verifying trig identities, you must simplify in order to show that both sides of the equal sign are the same. So I think I've told you guys a little bit about majoring in math in college before. I went to college thinking you major in math, you just do harder and harder problems. I found out you spend a lot of time just proving logically things you already took for granted, right? So this is sort of an example in that, except for I'm not going to make you write this where you like write out the properties that apply and the theorems that apply to this, because if you were majoring in math, you would have to do that, and that would make it more difficult. So what you are doing here is they have already given you the answer. They are telling you that sine cubed x plus sine x cosine squared x equals sine x. They are telling you that that is a fact. You have to prove that it's true. So, a couple things here. Here in bold letters, I have said you may not move anything from one side to the other. You are proving that the left side equals the right side. You cannot move something from the right to the left for these problems. Right. So in this particular case, there's not much I can do over here. So I have to make the left side become sine x. So I'm going to use some strategies here to make the left side become sine x. So on this first problem, we're going to do all our work on that left-hand side. The second important thing I must tell you, and there are always some students that really could be good at this if they would just listen to this advice right here. You've got to show all your steps, because the answer is there. I need to show the steps that get us there. I know you should get sine x, but if you say this, I don't know if you knew what in the world you were doing, or if you're just like, well, I got to get sine x somehow, I'm just going to write it down, right? I don't know if you know. So you have to think about me grading this. You have to clearly show me that you knew what you were doing. I'm not going to make the assumption that you knew anything. You have to show me that you knew what you were doing. So, yeah, I'd give you 0 points for this. Yeah. It'll be on paper. Yes, this stuff will be on paper. Yeah. And when we get, the quiz for this will be completely on paper, like the real quiz that we'll do next week. And on the test will have that graphing stuff and this on it. So the graphing stuff will be on Canvas, but you'll have a section that is on paper for this, because I can't grade these otherwise. This will be on paper. So your work has to be shown. I am usually not very picky about you showing your work, because, I think it is a good thing if you can do shortcuts in your head. This is not the case for this one. This is a case where you have to show your work. So if you are like Daniel Bautista and want to do everything in your head, despite how many times I tell you have to show your work on this, it could hurt you. But this stuff you must show your work on. Actually, when he took the quiz, he didn't want to do his work on any of the homework. When he took the quiz, he went like overkill to show his work. All right, so here we got sine cubed x plus sine x cosine x squared equals sine x. Oh, and one other thing I need to tell you, because I don't think we've seen this yet. When you see something like sine with a cube right here of x, this means sine, sorry for all these lines that are popping up for no apparent reason. That means sine of x cubed. Rather than put the cube out on the end, they put it right there beside of sine. They do that to avoid having to put more parentheses there. So when you see sine cubed x, this means sine of x cubed. And whenever you see cosine squared x, this means cosine of x squared. So this really means like I've got 3 sine x's here, and then I've got sine x times 2 cosine x's here. All right, so you know nothing about this so far, so you probably don't even know where to start. But I've got 3 sines right here, and I have 1 sine over here. That does not equal 4 sines because I cannot add them together because they don't have the same exponent. So they're not like terms. Think of this like it's x cubed plus xy squared. Right? So you're almost thinking like sine and cosine are variables. If I had x cubed plus xy squared, I could factor something out. What could I factor out? An x. But it's not x's. That was just like something you knew what to do with that I'm relating this to. I've got 3 sines here. I've got 1 sine over here. I can factor out a sine. Okay? So that would mean I did have 3 sines. I took one of them out here. So that will leave me sine squared x. And then for the second term, I had a sine x, cosine squared x. I took the sine x out. So I just have cosine squared x here. All right, is everybody okay here? Factor that sine right out of there. Now, you don't know much about this yet, but you did just write something down that included this. Actually, you didn't write it down because I printed it out for you. You would have if I didn't print it out for you. Sine squared x plus cosine squared x. Do you see it anywhere on your paper? It equals 1. That is a trig identity. It is a fact. Mathematicians have proven that that's the case. So, back here. Oh, wait. I don't want to do that. All right, go back a couple slides. Pythagorean identities. Sine squared plus cosine squared equals 1. Show your neighbor where it's at if they haven't found it. That is a fact. We are memorizing it. So if I've got sine squared x plus cosine squared x, what does it equal? 1. So I can replace sine squared plus cosine squared x with 1. I'm going to show that I'm replacing that with 1. That lets me know you knew that equaled 1. Alright? And then, what is sine x times 1? Just sine x. And the other side also equals sine x. And these are equal to each other. So we got it right. I feel like in these problems there's a moment where like it all becomes clear what you need to do, and it is a very exciting time. What's not exciting is if you never have that moment. We won't determine that final separation until we get towards the end of our time. It's just a figure of speech. Let's not analyze it too. Let's not analyze that to any greater degree. We don't want to get off on that tangent. Okay. All right. So yeah. All right. Okay. So here are just some strategies. This is in no way the list of everything you might want to try. But this is why this is difficult. Because for any problem, you might do any of these or a couple of these. But, like, I can't tell you exactly how to know which one to do. You just got to have, like, all these tools in your toolbox. And when you see a problem and you're like, that looks like I could factor something, I'm going to try my factoring tool. And you're going to see if it works. Sometimes the factoring tool does not work. You got to put it back in your bag and go get a different tool, right? Yeah. 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 If you like the rules, there's still rules you have to follow, but not rules that tell you. So you can do things illegally. You can break the rules, but there is no rule that tells you here's step 1 and here's step 2. If you want a bad grade on the quiz, go ahead. You achieve a good grade on the quiz by not breaking the rules and getting the right answer at the end.
So don't break the rules.
Correct. If you want to be a rebel, if you're like Miss Hyatt said, I can't divide both sides, move something to the other side, but I am a rule breaker. Yeah, it will. I'm telling you, if you want to break the rules, go ahead. It's not going to work out great for you. All right. Okay. All right. Okay. So, typically, I usually try to work with the more complicated side first. Although there can be times where it may work to do it the other way. Basic trig identities to simplify. This is like you're changing all your tangents to sine over cosine. Because a lot of times we can't do much with tangents. Factoring, like we just did on the last problem, is a good strategy. But sometimes it's already factored. And sometimes you might want to multiply them back together. This depends on the problem. Sometimes you will have fractions, and you will not need to get like denominators and add them together. Something we'll use often is changing everything to sine and cosine. So this is not like a list of all of the possible strategies, but it's just several things that we're going to try. Okay? And as we do more problems, hopefully you'll see like what types of problems these different tools can work. The other thing is, this is also frustrating for some students, like Macy and Avery can do the same problem completely different ways, and they can both be right. They can both be right. So you can take a totally different strategy than somebody else and still get it right. Although some problems lend themselves to that more than others. Some of them have more of a straightforward way to do it. But for lots of these, there's more than one way to do the problem. All right, so let's look at example 2. All right, I got cotangent over here. I got cosecant over secant here. So I need this to equal each other. Now, you can work on one side only, or you can work on both sides. But you need both sides to equal the same thing at the end. Okay? Right. You don't necessarily have to get this to equal cotangent. You just have to get it to equal, like you can work on cotangent. You can make cotangent cosine over sine. Then you can try to get the other side to match that. Or you can make it equal cotangent. It's up to you. All right. Let's work on this right-hand side first, because it's a fraction. I got cosecants and secants. I think it's going to probably help us here to change this to sines and cosines. Okay? So if I change this to sine and cosine, cosecant is 1 over sine theta. And secant is 1 over cosine theta. Now, it is easy when you start getting these complex fractions to lose your place. And particularly, like, also on these, I want you working down. Please do not work across. Because if you work across, you run out of room, you go to the next line, I can't follow it. I know some of you don't like to work down, but I need you to work down for these. Yeah. Yeah. So, it might be helpful to put you like a line between each step, because sometimes like the fraction of the first one runs into the fraction of the second one. You need each line to be equal to each other. All right, so I've got a complex fraction. You pretty much never want to have a complex fraction. Dividing fractions is easy as pie. Flip the second and multiply. So I have 1 over sine theta times cosine theta over 1. Show that step, okay? Don't just assume I knew that you were flipping and multiplying there. Show it, okay? Then when you multiply that together, what do? You just multiply straight across. You get cosine theta over sine theta. What does cosine theta over sine theta equal? Cotangent. Which is the same thing we have over here. And we got it right. Okay? Alright. Alright, so Sophie? No, I would not. So, as long as it's on both sides. So, what you would do if you did it that way, so it does have to be the same on both sides. So, if you left it like this, I would count off. Because this side is cotangent, and this side is cosine over sine, and I will make no assumptions that you know that's true. But, if you just said that this is cosine theta over sine theta, which is true, right, and left it like this, that'd be perfectly fine. So you need to make sure the bottom line of both of your sides is the same on both sides. And you know, if one side's a lot longer than the other, just draw yourself an arrow down, and at the bottom you should have both something equal to it, exactly the same thing on the other side. So it does not matter to me whether you do this or whether you did it like the first and where I go all the way to cotangent. Either one's 100% correct there. But it does have to equal on the same side. And here's a hint. If you're stuck, you know at the end both sides have to be equal. So even if you don't know how to do the problem, even if you're doing crazy stuff that you're just making up here in the middle, you're just, creating your own ideas here, still make sure both sides equal each other on the end. Because maybe you magically did something right that you didn't know, and you were one step away, and it's going to look like you knew what you were doing even though you didn't. Now, it might not work out for you, but if you don't have a matching on the end, you for sure did not get the answer right. So, I will not think lowly of you if you do just, write something where it equals each other at the end, because at least you know it has to go that way, right? Okay. All right, so, let's see. All right, we're going to do this one really, really fast, okay? So you've seen one more. All right. Tangent, cotangent. This is sine theta over cosine theta. Cotangent is cosine theta over sine theta. I'm going to leave secant for right now. I'm going to leave it like that. What's going to happen when you multiply that together? The sines cancel, the cosines cancel. You just get 1, right? So I've got secant squared minus 1. All right, now I'm remembering tangent squareds and secant squareds. What was the identity that had tangent squareds and secant squareds? Tangent squared theta plus 1 equals secant squared theta. All right, that is an identity. All right, so that means secant squared can be replaced with this, right? Secant squared can be replaced with tangent squared. You can't move things to the other side. So you can't do that. That would break the rules. Rule breaker. But we can do this. We can replace secant squared with tangent squared plus 1. So we're taking secant squared and replacing it with tangent squared plus 1. And then what happens when you have tangent squared plus 1 minus 1? It is just, I should have a theta there, tangent squared theta. which equals. You can also make secant 1 over cosine squared and do it that way. It just takes longer. And I'll show you guys that tomorrow. Okay.